Hi, good morning, good afternoon, everyone. Welcome to our opening panel at Quantum Tech. I'm delighted to welcome Philippe Duluc to moderate this session. Philippe is the Chief Technology Officer of Atos Big Data and Security and is also a distinguished expert. He has a very keen interest in scientific and technical domains involved in digital transformation, for example, cryptography, cyber defense, advanced computing, artificial intelligence, and of course, promising quantum technologies. Philippe, the floor is yours. Thank you.
Yes, thank you very much. I am also supervising the Atos Quantum program, which was launched in 2016. This innovation program has produced the quantum learning machine, the QLM, a commercial appliance product providing users with capability to program, debug, compile, and emulate a quantum code. This QLM has been sold around the world, and we are now preparing the next step, which will be the quantum accelerated supercomputing hybrid platform planned for 2023. Yes, I'm very proud to moderate this roundtable because industrial adoption of quantum technologies is really key for the future of this emerging industry. Now, I suggest our panelists to introduce themselves briefly, background, current role, your priorities. Ladies first, Elitsa, the floor is yours.
Thanks, Philippe. Hi, everyone. Hi from Israel. I'm Elitsa Kioseva, and I'm an applied quantum computing scientist at Boehringer Ingelheim. I joined the pharma industry. Boehringer Ingelheim is a German pharmaceutical industry, and I joined about 7 months ago. It's really exciting to be working on applications and on algorithm development for drug discovery. Previously, I have a PhD in quantum optics from Sofia University, Bulgaria, and I was subsequently a fellow at MIT in the States and also had a Marie Curie Fellowship at the European Commission. And I'm very happy to be on the panel.
Okay, thank you very much, Elitsa. Perhaps Brian? Could you
morning and good afternoon, everyone. Thank you, Philippe. Much appreciate it. Good morning and good afternoon to everybody. So my name is Brian Standen. I work for BASF. I have a couple of roles at BASF, which is probably not uncommon for many people, but the first is that I lead digitalization in materials and chemicals R&D in North America. And here we're looking at how we practice digitalization within our R&D platforms and how we implement that across the board in North America. And then secondly, and probably more relevant to our discussion today, is that I'm the global head of next generation computing. And next generation computing is, as you can tell by its title, is a very broad topic, but it's meant to be. Here we look at advanced computing paradigms and how those will impact BASF now and in the coming years as they become ready. And of course, key within this and my top priority today is quantum computing. I've been with BASF since 2013, came here as part of an acquisition of a small biotech firm out of California. And I have a degree in anthropology and English, and I have an MBA from the University of North Carolina, Chapel Hill. But very excited to be here today and talk with you about quantum computing.
Thank you, Brian. Thomas?
Yeah, hi, my name is Thomas Immer. I'm from Merck KGaA, and actually, as a short disclaimer, there are two Mercks, and inside the US, it's called Merck & Co., and outside of the US and Canada, we're Merck KGaA. So I'm from this one, from the original one. Yeah, I'm actually 20 years in Merck, and I joined as a business developer in the past. I have a PhD in biophysics in my former life. I did this, and I had different roles over my career in Merck. So I started as said, in business development, and then moved over to IT, where I did project leader and business analyst for long times. And then 4 years ago, I started something which a cool title, which you call innovation incubation, with the idea to look at novel technologies, at least novel for us, to make it tangible and investigate if it has value to use these things. And since then, I'm also a bit of a tech scout, deep tech scout, and I work mainly in IT healthcare in the R&D area, and also look cross domains. So we also have a performance materials electronics unit and a life science unit. And I'm looking really how we can use this novel technology to add value to for our colleagues. starting from variables in clinical trials. Also, as Brian said, computing, novel computing. So neuromorphic is one hot topic for us, and of course, quantum. And on the quantum topic, also sensors are relevant for us, where I think in this panel we focus more on the computing part. Really exciting. Thanks for the opportunity to be on this panel.
Sure, thank you very much. Steve?
Sure, yeah, thank you, Philippe, and good morning, good afternoon to everybody. So my name is Steve Flinter. I work in MasterCard Labs R&D group. I'm based in our European Tech Hub, which is located in Dublin, Ireland. My role within Labs R&D is that I lead our group focused on artificial intelligence and machine learning. And about 18 months ago or thereabouts, we expanded the remit of my group to also encompass quantum computing. In terms of background, I've a PhD in artificial intelligence, and I've spent most of my life in the software engineering, software development world in one shape or another. And I guess we've been leading through my group, leading out kind of MasterCard's initiative within quantum computing, trying to understand how it and indeed other emerging technologies is going to play a role in the product development roadmap that MasterCard will have going into the future.
Okay, thank you very much. What is clear is that you are representing very diverse industries, and I'm very curious to know how quantum computing came into your radar. Can you give us a brief timelines from early scouting to today? Who will begin with this question? Brian, perhaps, or?
Sure. I'm a little slow to the unmute button, but I'll do my best. So, for me, one of the things I didn't mention about my career is that I actually also spent time in scouting. And actually, I did that from 2017 to 2020. And for me, seeing quantum computing now become part of this entity that we have of next generation computing within BASF is almost the sort of actualization of that scouting effort. Because for me, it really came on my radar late 2016, early 2017, at least as it's been starting to develop. Now, it's very easy for me to argue that for our quantum chemists, this has been on their radar for many years. It's not anything necessarily new per se to them, but the development and where it's at today, I think, especially over the last 3 years, has been quite, I think I wouldn't be remiss in saying it was rather breathtaking in how much it's developed so quickly. And so over that time, we started to kind of examine it a little bit more with researchers and really starting a sort of organic approach to it out of research and growing that up and really examining where we thought we could have the biggest impact with the technology if it comes to fruition, and frankly, also testing the technology, given the state even 3 years ago of where it was. And then we've sort of stayed with it with that through our internal research, through working with a couple of outside parties to understand how these near-term, these NIST devices can impact us. Can they deliver value now? What's the path to the future? And we kept that route. Last year, we actually formalized this into a more of an organization, which is what I lead now. And it's an organization that's community-based. So we take first this sort of bottom-up approach across all of BASF, which maybe is a little bit unique in that we're a very science-driven company. So you would expect that we would probably focus primarily on R&D, and certainly that's a part of it. But we see a very broad impact for quantum computing in multiple areas within the business. And so I actually think of this much more as a enterprise type of architecture that can bring us value in different ways across different use cases. And I know we'll talk about use cases here in a bit, but if we think, for example, broadly about something like optimization, I mean, there's optimization problems everywhere. So we take that sort of broad approach with a bottom-up push to come up with good ideas for us to kind of take on and see how we can build and test out the technology. And we've been doing that pretty deeply for the last year, which is great because we reach out throughout the company to sort of embrace people and bring them to the technology, and then also reach to the outside world to bring that all together.
Yes, thank you. Thomas, do you have the same in your industry?
I think it's maybe kind of the same eventually, because we're also a science computer and we're not so far away. I mean, we can even wink to each other from. But I think it started also for me, being physicist. I was always curious on the fundamentals of quantum mechanics, more the philosophical part, the observer. I mean, everything that is science fiction-ish and the cool part of it. But also, of course, for potential technology applications. And I think in the recent 4 years, it's amazing what happened from these vague concepts then to Google's primacy, etc. And so it started in principle as a one-man show where I was founding a bachelor thesis. And he had different options to work either on artificial intelligence or virtual reality or quantum computing. And I want to do quantum computing. Is that, are you really sure you want to do that? So he did. And this was where we first learned of qubits, that there is something. And then there was this company, Microsoft, who claimed to have things, and Google. So it was very early. And it happens that we, 3 years ago, we had a kind of convolence from a quantum chemist joining our company in the digital unit, and somebody from Merck Ventures branch who also joined, and were looking to invest into quantum technology. So we found something like a quantum task force. So it started with 3 people. And meanwhile, we organized some conferences also for external invited guests. And we have actually more than 70 plus people actively cross-company working on the topic, a bit in a viral mode. We try to get it organized, but the company has a bit difficulties to find a way to be flexible and viral and process oriented. So we still do this as a kind of a hobby organization, or motivated hobby guy. And yeah, of course, we focus on computing and infrastructure topics as a potential provider. But also one thing is which very close to my heart is the paradigm shift in understanding what quantum speed up could be. So this novel paradigm. And yeah, so we have meanwhile several partnerships. We have some major investments in the company CQC, for example. And we have a strong partnership with HQS. I think he will be also speaking later. And of course, we have a lot of networks, and I think we might talk later on the importance of networks.
Okay, and for Mastercard Labs, Steve?
Sure, yeah. So I guess we started to look at this area about 18 months ago or thereabouts. When people think of quantum computing in the financial services space, I guess the initial thing that comes to mind is immediately around security and integer factorization and you know the kind of attack of crypto systems and all that kind of stuff. And while that's certainly very relevant for MasterCard, and we have specialists who focus on that area, the approach that my group took was to look more at, you know, what are the application use cases that may be relevant to the business in terms of internal efficiency, and also where we felt there may be, you know, down the line product opportunities where you know a quantum computing approach could lend some kind of business value, and that's very much the approach that we took. I guess in terms of, you know, how we rolled that out, initially our kind of entry into the space was to start to collaborate with external partners who are developing technology in the area. We partnered with IBM Research Labs, who have a quantum research group in Ireland, a number of Irish universities and startups, and kind of developed a consortium, government-funded consortium around the area. And that certainly gave us the impetus to kind of enter into this world and to partner up with people who are kind of deep on the technology side, which at the time we certainly were not. And then kind of in parallel, we started to develop our intuition around, you know, what parts of the organization were developing software technologies that we thought may potentially have, you know, have a quantum application. And I think as we get kind of into the conversation, we can talk more about that. But that was essentially our remit into our approach into the space.
Yes, but quantum computing is rarely a true deep description. The question is about the legacy. Is this research activity driven separately as a new innovative project, or on the contrary, embedded in the legacy in a more incremental way? How do you interface with the legacy? Elitsa, you can take the point?
Yeah. Thanks, Philip. So, as at Boehringer Ingelheim, we are quite dedicated to really exploring and finding the applications of quantum computing to the pharma industry. So we are definitely an activity on its own. We have a quantum computing lab where I'm part of it, and we are several PhDs with diverse backgrounds. I think that's also very important. Ours from academia industry and also even from the private sector, from VC funding. And we are really dedicated to finding the best use cases that will push forward drug discovery process. In terms of course, interfacing with the rest of the organization, that's very important. Because we really want to go and solve the pain points of the rest of the organization. Like our purpose is more or less to serve and to make the life and work of the rest of the computing teams easier. So we have very strong interface, and we are really supported by computational chemists, by the IT at the BI, and so forth. And this is also the way that we find a way to really bring value, because we all know that the hardware is still not advanced in order to bring some value in the next few years. But by really interfacing with the legacy, as you call it, Philip, of the company and with the rest of the computational methods, and identifying the pain points that quantum computing would alleviate, this is how we take this approach to bringing value to the company.
On this legacy question, Brian, do you have the same feeling?
Yeah, it's very similar. I mean, I think at least it brings up, some interesting challenges that we face, right? Is how do you bring the organization along with you in particular, and how do you reach out across the organization to find those interesting use cases to drive the technology? Because you need both. We can't really just have the tech push, but we also need the pull, I think, to make it successful. So as I was describing a bit, we're community based, and our community is very broad, and it started with just a few people, not unlike what Thomas was describing, who were interested in quantum computing and maybe had physics backgrounds or interest in quantum chemistry, and thought that this was sort of a natural fit. But what we've seen as we've continued to sort of advertise really internally, right, and show that quantum computing can have impact broadly, is how people in different areas can benefit from this. So my comment before about optimization problems lived everywhere is maybe a little bit flipped, but it's also accurate. And so when we pull people together, we can start by talking about those type of problems, right? So the legacy organization, if you will, has these type of problems that are hard to solve. How do we then potentially attempt to solve them with this new technology and then derive the value? And this is a tough argument, and Elisa, I think, was also alluding to this, right, is that we know today's machines can't necessarily deliver the type of value that we know can come, but we still need to be working on it. And so how do you balance that, right? Is, can you give me a use case that can motivate what we're trying to do, but I can't promise you that we're going to have great results. It's just a bit of a balance. And I think when you find the forward thinkers, and that to me is quite a challenge, but also quite necessary in your organization, is to find the forward thinkers who will join you on this journey. That is where you'll have the success, right? So you've really got to make the push to find those people and embrace them in this community, at least for us.
Okay, and Thomas or Steve, is it the same journey for you? Or?
I mean, I can.
Thomas?
Steve, go.
Sorry, I would agree with a lot of what Brian said. I think that idea that, we know the current generation of technology is not going to outperform, best in breed classical technology, but being able to find the use cases, get the learnings, do some initial experiments, get people interested and excited about it, then gives you that opportunity to go and actually lay the groundwork for, a generation or two technology from now when those advances will be made. And so for us, it's very much around kind of finding the use cases now, doing some initial experiments, getting a sense as to these are going to work, these are not going to work when the tech can catch up, and then building that kind of organizational interest and excitement around it to say that when the technology is there, we'll be ready to make best use of it.
I think for us, it's also a bit of, like everybody said, a bit of a dance between something new and a very promising technology, and now giving the NISC gap. We all know that the interesting stuff is not yet possible to simulate to an extent we want to. And it will be definitely an iteration. And as you were asking for legacy, Philip, so for us, legacy is benchmarking. So, we were running exactly for this master thesis, a very interesting master thesis, by the way, on the potential business value of quantum computing. And there, many people said, okay, if you look for application or being a provider, focusing on application, quantum computing is one of, I don't know, 20 tools. Yeah? Why should I switch? I have 19 things that work better. And we do quantum chemistry, but not on a quantum computing hardware. So where's the benefit? And I think this is really something where the new thinking comes into play. So how do we translate our existing problems so that it could work in one of these very few algorithms that provide quantum speed up? So I think that's really the dance, and how we embed this in our overall computational changes. I mean, in the healthcare industry, people are dying, and we produce a drug, and we start from here, and the gap is so big, and where in this value chain could we provide the quantum computing? It's not so obvious. That's really a dance.
Yes, this legacy question is important, and it's important to interact with the legacy. But we are not alone in our industry. There is the external world. Quantum ecosystems are growing around the world with public labs, universities, startups, large and medium companies, even investors. Are you considering it is beneficial to cooperate with such different partners? Does it bring value? I guess it is, but Elitsa.
I think it's definitely beneficial, and I think everyone on the panel actually is already collaborating with private companies and also with universities. So it is also the same for us. Of course, as also Thomas said, especially in our case for pharma, the value chain is very large. So designing a new drug is a very big and complex process that takes over 10 years. So you can have specialists that are really, big, and they can really zoom in on a particular part of the value chain and have a team that is really dedicated to improving that. And that's very hard to actually make in-house, unless you have thousands of people or at least hundreds working on quantum computing and quantum algorithms. So we are also partnering with external partners, and it is very important also the startup scene, small dedicated teams, and of course none of us here also is from the hardware point of view and hardware providers. So ultimately we are all partnering with a hardware provider of quantum computing, and that's the big companies with very large budgets and teams building hardware. So it is very, very important.
Who want to react? Brian, for example?
Yeah, those are excellent points. I think all those ecosystems are critical, right? I think we need the academics to keep the sort of push on the long term. We have startups that think about the sort of now and what they can do now to build their business. And then we have the government, which I also think feeds into both, right? Especially as we see in Europe in particular. I think one thing very clearly, and I say this very unashamedly, is there's a lot of money on the table from governments that we should be going after and taking advantage of as industry, but to further the field as a whole, right? And to bring what I think is the unique aspect of us is our use cases to help motivate these things. But I also think it's important from another perspective, two other perspectives actually, thinking about talent and the sort of long-term talent pipeline. We want to be involved in those conversations because obviously the applied nature of what's done in research, especially in academia, but even with the startups, how they can apply those technologies, they're going to build the expertise there. They need us to help, I think, to foster those ecosystems and to help push that along. So I think that's one critical place. I think the other place where it's important is in understanding how the technology evolves, right? How we can be players in that to help facilitate that evolution. So Elisa make reference to the hardware manufacturers, and we know that that's a very diverse landscape at the moment. So how do we then participate in that and help to steer it in certain ways? And when I say steer, I mean, you know, by guiding it with our use cases, not necessarily some sort of, you know, active steering per se.
Thank you. Thomas, I guess this question about ecosystem is critical for you too?
Yes, and I mean, really the beauty of external collaboration is you have, of course, open mindset, and I mean, as a company, you're a bit blind. Even if you're a diverse company, you're super blind. And we have to learn from the outside, and specifically also I think it's a network of networks. You know, everybody has now his own network, and they have their networks. For example, in pharma, we started 2 years at the Q2B conference. We started something which is called Q-Farm. I think we have now, I don't know how many, everybody is a member of Q-Farm, including startups and service providers and chemical and pharmaceutical industry. So we talk among peers to confirm our bias. And then we have to go outside, of course, to look industry consortia. For example, in Germany, we're trying to start one cross industries to learn from each other with finance, insurance, car manufacturers, etc., just to share the problems and types of classes that we could work on, and even build strange collaborations. For example, we just learned that we have something which is might be very good for the production of the NV center diamonds. Yeah, and this is in the life science. They never have heard the word qubit. And just by these kinds of discussions, we also start internal revolution, or at least evolution. And something which is also interesting, I think you mentioned the young generation. And we are also exploring something like gaming, so quantum gaming. I'm a private investor in a very cool company, so you can reach out to me later. But also the education of quantum features in a let's say, unobtrusive way. So even in kindergarten, you could learn maybe even better than in university what quantum features are. And also sponsoring hackathons that people really play with it, because it's so wide, observer dependent. Every observer brings a new observable, which you might not have seen if you're cooking in your own.
Steve, on these external partners, do you have the same feeling or experience?
Yeah, look, I think all the other panelists kind of covered a lot of the points I would have made. I think for us, it's certainly critical. You know, we're always going to be at that top level of the stack, interested in the applications and less so in the technology, other than being an enabler for those applications. I think Brian, however, made a fantastic point. And I think one of the great advantages of the partnerships that we've built is not only that we're learning from experts in the field, but we're also able to feedback the types of problems that we're interested in and the applications that we're interested in, which in turn is going to guide the development of the technology. And ultimately, you know, a lot of these companies, you know, unless they have partners who have the real problems, are not necessarily going to know what the right approach to build technologies that will solve the problems that industry have. So I do think it's definitely a two-way street, and we've definitely seen we knew coming in that we get the benefit from working with the partners, but we've seen it flow the other way as well, which I think has been very interesting.
Yes, thank you. And Brian, do you want to conclude this topic on the ecosystem?
Yeah, one other point that I just forgot to make that I thought was important about the ecosystems is that it's also a good way for us to de-risk both ways. So going back to Steve with the sort of feedback, right? As we've already noted, right, some of the current return on those investments right now is not necessarily as tangible as we would like it. But if we can de-risk that together with these ecosystems for both parties to make it interesting how we push the field, I think that that's an important element of why these ecosystems are important, including industry as an ecosystem.
Right, you're right. Thank you. I see the chat. I see that we have many questions. And thank you everyone for these questions. And among these questions, we have several questions about use cases. It's clear that to convince the final users to invest in quantum computing, we need to show use cases demonstrated a real quantum speed up. Can you give some insight into current use cases that you are exploring? Elitsa, for example, to begin with this very interesting topic.
Yeah. Of course, the use cases are the most interesting after and together with the hardware. So in terms of the use cases that we are working on, I can say and I can share that we are mostly working on simulations of quantum chemistry and very precise simulations of quantum systems. And this is clear that that's our goal because of the fact that our systems, molecules, are actually very well suited. They're excellently suited to be simulated on a quantum computer. So we are really interested in creating this kind of quantum mechanical controlled twins of our molecules on quantum chips and being able to extract some really accurate properties from them. So this is definitely the use case, one of the use cases that we are working on, and I would say the most fundamental one. And of course, there you have to consider both NISQ devices as well as fault tolerant. So the algorithms and the tools that you would use for a NISQ device are rather different than the ones from fault tolerant. And we really hope that based on our work at the moment, we will see that when quantum hardware is available, we will know actually how to use it. And we will be able to apply the algorithms that we're developing now in the next 5 years plus when we have fault-tolerant quantum computers. So I think it's fundamentally important that companies and big companies, the end users of quantum computing, start working at the moment on the algorithms, on the application layer, even though we don't have the hardware, because it takes a lot of time. Like we need to meet somewhere halfway. So the algorithms need to evolve to require less computational power, at the same time as the hardware evolves to have larger computing powers.
Yes, thank you. And Steve, on the finance domain, do we have examples?
Sure, yeah. I guess most of the use cases that we've looked at are broadly in that optimization or combinatorial type space. For those who are kind of less familiar with MasterCard, obviously you know us as a consumer brand, but we're a tech company that sells into the banking and payment space. So we have a lot of kind of enterprise software products that reach out into that area. So within that, we've looked at applications in areas like loyalty and rewards, which is a big part of our business. Things like network optimization, fraud reduction, anti-money laundering, and machine learning. So there's a few different areas that we've found potential applications for quantum computing, and have done some early experiments to kind of validate that we're at least pointed in the right direction. But certainly in the enterprise kind of software space, most of what we looked at is that kind of combinatorial and optimization type problems.
And Brian, do you have other example of use cases you are working on?
Yeah, I wish I could add, but both of these are very similar to the types of use cases that we would follow. I imagine Thomas and Elita and I have a similar interest in the quantum chemistry piece in particular for the long-term dealing with molecules. And I think that's very natural for how it evolved for us, for example, right? But maybe along the lines of the optimization problems, for example, something we're thinking about falls into the supply chain and logistics category, which of course is sort of this well-known use case, but it just impacts all kinds of things for a business. And so, I think a lot about, determining optimal routes for fleet management is a really interesting use case for us, for example. And that impacts directly into supply chain and but even internal operations, right? Depending on how big you are and the types of plants or logistics that you're even dealing with within a small space, because I hate to say it, but I will, the traveling salesman problem is not the easiest thing to solve. And it rapidly hockey sticks very quickly in terms of complexity. So I think that actually makes a lot of sense. But yeah, very similar to everybody else's challenges.
Let me just add on these traveling salesmen, because we're also, of course, working on sustainability goals, and one of the goals is to get rid of this disease. Yeah, I will. And we have, of course, NP-hard, or even more than NP-hard, logistic problems to model with lots of parameters, and we have maybe a mathematical model that comes to its boundaries. And in the future, if you really want to be interactive and leverage live data to really steer your material supply to where it makes most impact, I think that's definitely one of the optimization topics. And I think on top what we said, and I see also that there are questions on how to choose the right case. We have 3 different teams. Yeah, one is the team gate, doing quantum gate. The other is the team annealing. I'm relatively alone, to be honest, on this team. And then we have also more a team philosophy, and they are really tackling how can we reformulate our problems. For example, we do something in clinical trial optimization. How do we plan a clinical trial with many parameters in the most efficient way, which is standard, classical, Monte Carlo, etc. And the idea is to make this as a kind of an optimization problem, to have the system propose us the parameters. So we're just starting an RFP on that, but the challenge is really to transform problems from how we do them. Like in mathematics, you do Fourier transformation, you solve it in the Fourier space, you transform it back. That's my hope, that we find something similar for our industries, to do a quantum transformation and solve it here and transform it back in terms of thinking.
Thank you, Thomas.
Somebody wants to help me, just reach out.
Somebody want to react or to add something on this very important question of use cases? If not, I propose to switch to another very important topic. It's education. We know that education is key to develop a quantum computing business. It's key. And what are you doing in your industries to foster quantum awareness of internal workforce? Who want to start? Elitsa, Brian, or?
I mean, I can start if you don't mind. So because
yes,
we are doing a viral approach, because it's really difficult to make this quantum disruption a process. So it's kind of the big question for a big company: how do you deal with all these troublemakers who think they have a new methodology, who could make a new business or whatever? And as said, we have a task force and we do tech talks. So I gave a 90-minute lecture, everything you ever wanted to know on quantum computing, from algorithms to hardware, etc., which was tough, but we did it. And we do a lot of one-on-ones with our management, top till down. So I spoke to our CEO and we talked to the shop floor researchers. And one thing is really we pitch, let's say pitch opportunities, internal pitching, where we see we might think quantum could contribute, and then we educate them and say, do you know what quantum computing is? No, not everybody knows what it is. And I think this is a way to get in conversation and explaining, to help the colleagues understand, also do quantum thinking. There's something like a superposition. What can I do with it? Nobody who is not physicist had ever thought about what a superposition is. And this is a kind of a brainwash, positive brainwash inside the company, and it's slow. It's really slow, but I think it's one of the approaches to do it bottom up. Other approaches are top down. I know other companies are doing top down. I think it's coming back to a dance. But the internal education is fundamentally important, because otherwise you just have resistance and not support.
I agree with that. Other experiences, Elitsa, about the training, top down, bottom up?
Yeah, I would say that we actually pointed to both directions. So we did, of course, we had to do education at the top level, at the CEO, because we are this quantum computing lab. We are part of the company, so people had to know what they're investing in, and it created quite a lot of noise in terms of our partnerships. So we have been talking really and trying to gauge the expectations, and for the higher level managers to know what are the expectations for the next few years, and that it's kind of a long-term investment. I think we all would agree that still at the moment, quantum computing is a long-term investment. And that's why also Boehringer Ingelheim is into it, because all of us represent companies that will be around in 10 years. So we'll be around when quantum computing is a mature platform. So it's very important to start investing now and not to really expect results now. And on the other hand, we are really talking to from bottom up. So we are talking to many scientists, many researchers, data scientists, quantum chemists, biologists, and many other technical people from the company. And we are trying to find a mutual language. And to really also not overhype quantum computing, because there are many problems that are still not clear whether quantum computing will be beneficial if we apply it to them, especially ones that deal with big data and so on. So we are really trying to set the expectations and to educate the rest of the company. And mostly we've done it, like Thomas said, through internal talks, large ones, you know, with thousands of people in attendance. And when we have more dedicated presentations, depending on the team, so then we would really try to change our presentation in front, depending on which team are we presenting in front. So overall, this has been how we approached the education within BI.
I guess it's also a priority for you, Steve or Brian.
Yeah, I mean, I can go. Certainly, yeah, I think the same as we mentioned already. Really, it's a challenge to try and get the organization to understand, you know, both the potential as well as the current limitations. And for us, you know, part of the education that we did was working with the likes of product managers and project managers who are kind of steeped in, you know, the current set of technology and products that we build, and try to give them a sense of, you know, this is what a problem that might be a good fit for quantum computing looks like. And I think Alicia mentioned kind of big data problems are ones that MasterCard is very, very familiar with, and we have a lot of expertise in, but they're not necessarily the ones that are going to be relevant for quantum computing. We need to look at different problems, or at least formulating those problems in different ways. And that's the type of education that we've tried to do with some of our product teams around, you know, how can we identify those use cases that we think are going to be relevant?
Yeah, maybe I would just add, I think Elitza was saying this as well, is that certainly our first pass at this is a bottom-up approach through this community that I mentioned, but we also do need that sort of top-down. So I call it the sandwich approach, right? You need both, because you need to convince senior management also of this other part of the investment. Once you find these interesting use cases, it's sort of this interesting conundrum of having the use cases that are attractive enough, but yet somehow getting then people to believe that you can tackle these, but not in the near term. So it's kind of a strange place to be at times, I think, as everybody on the panel has already alluded to. But I think one of the bigger questions we also ask ourselves is who needs to be educated in this, right? And I think that's one of the things that we take maybe as a learning from AI is how deep do you go? How far do you take people on this part of the journey? Certainly we want to go together, but do we need everybody to understand the technical complexity behind it? And so a lot of times we're actually reversing our thinking instead of leading with the tech, because I had this direct experience is I led with the tech and I lost people. But instead of that, maybe flipping it to actually have the conversation in one-to-ones, in presentations, to say with people, what is a problem that you cannot solve today that you think is really hard, right? Mm-hmm. Because you have them, every part of your company has these type of problems. And that usually opens up the conversation because it's much more on the sort of level of the person, right, in their domain that they really want to have the conversation in, because that's what they know. And so then it's more incumbent upon me to understand how that technology can apply. Or I shouldn't say just me, but the team, right? And I think that's a critical element to really breeding the success of trying to find the use cases and bringing people with you in the journey. And that's been reasonably successful for us. I mean, I don't think we have, you know, hundreds of millions of use cases, but we certainly have a good set. And I think that I feel very good about that.
Okay, no, perhaps just some minutes on the hardware. What do you think about the competition between all these qubit technologies like superconducting, trapped ion, cold atom, or photons? Have you could you forecast something for the future? Or what will be the winner? Or I guess you are really interested in and you are monitoring this. I don't know who want to answer this. To begin to answer,
we are materials providers.
Thomas.
So I think they are all tricky. They all have their strengths and they all have their weaknesses. It's a Radio Erivan answer at the end. But, I think personally, if I would bet, I would say we have not seen the technology yet. I'm personally really convinced that something biological is the truth. Just public coming out, but all these technologies are dependent on cryo. It's extremely cold. It's extremely ultra vacuum, and nature uses quantum processes in the cell, in photodynamics. And I think it might be an accident to discover the real true qubit, which is stable enough. I think personally, from a materials provider, so there's the chip technology. Yeah, I mean, it's making progress. We have seen the ions and X. I mean, those guys, they're brilliant engineers. So it's fantastic what happened in the last 2 years with the ion traps and the photonic approach. I also very much like. And everybody has their one single problem. If just you could give me a miracle, I could solve everything. And everybody has a different challenge. But, yeah. So I think we will see. We have not seen the truth.
Sure. Do you share this feeling, Elitsa, or?
So my personal opinion is that we'll have photonic ion and superconducting qubits is going forward, and I think that they would ultimately also be specialized according to the use case, because ultimately you would be able to, when the systems are larger, implement and simulate different Hamiltonians according to your needs. So I think that all of these technologies will continue to exist, and companies will really pick and choose which ones they use for their algorithms according to the Hamiltonian that can be realized in the system. And I'm very happy to see this race. I think it's bringing a lot of education also to the community, to the outside world, and it has really advanced quantum computing technologies in the last few years. I think it's only a positive thing. I'm very happy to be on the application side of it, but my forecast is that all three will survive in different shapes.
Maybe I just forgot the NV centers, because this is a bridging technology. And you definitely have, I mean, we did not invent the transistor for building a computer, but for amplifying signals. And I think the same could be true, that the NV is a bridging technology for all these sensors. And it could be also leading that. I mean, Germany is just trying to fund several hundred millions for building their own photonic spin qubit NV center thing. So definitely there's also
Definitely NV centers are the best, I think, for sensing. NV centers will be the leaders for sensing, but for computing, I think trapped ions and superconducting units are better.
For me, I 100% agree with Elitsa on this. I think we're going to live a heterogeneous environment in the future, depending on the problems and which problem fits to which type of hardware platform as we go forward. I think one platform we're forgetting about, though, is classical. We're certainly going to live continuing with a classical platform, because digital computing solves many problems today that it's really good at solving. And so I think it's the other part, as Thomas was talking about bridging, is also we need to bridge those two worlds and continue that bridge, because I don't see that going away anytime soon.
Okay, understood. And Steve, to conclude this discussion.
Yeah, I mean, I guess we don't have any kind of strong view in terms of the underlying physics. I think one of the challenges that you'll find users of this technology is, there are only so many hours in the day and days in the week, and learning about each of those technologies and trying to stay current on how to use and best use each of those is certainly a challenge. The other technology that I think Thomas mentioned earlier around quantum annealing is also kind of very interesting, and is one that at least from our experiments, is one that's likely to deliver business value probably sooner than the gate-based approach. And so, we're certainly looking at both the gate-based and the quantum annealing approach in parallel. But which of the underlying gate-based approaches will win out? Very hard to know. But I think the fact that there's lots of money going in to try out all of these different technologies would give you hope that if one does fail spectacularly for whatever reason, there are 2 or 3 others in the pipeline. So I'm sure that the picture will kind of become clearer over the next few years.
Okay, thank you, Steve. I see that we have only 5 minutes left. Just when I look at the questions, there is a question, several questions on the same topic. Considering that CEO, CXO are very short-term oriented, what do you say when people tell you quantum computing is not mature and this is a waste of time to prepare for it now? Do you have some arguments to give, to share with the audience? Elita, on this topic, it's complex question, but so, important.
In our case, thank God we are not in that position because we are a private company. So the view is long-term. And we are not really, in this kind of short-term bring value race. So our answer to that is something I alluded also earlier. It's if you want to use quantum computers in the future, it won't be so easy. So you really need to start now in order to find the use cases from your particular organization and to find also the solutions that will provide some speed up. And this is not at all a trivial question. In fact, it is a very, very difficult question to answer, and it will require quite a big investment in terms of teams and also time in order to be able to find the solutions to the problems. So I think really, if companies want to start benefiting in the future, they have to start developing solutions now. And the other thing is that the quantum computing field has been quite open until now. Most of the results are published, more or less it's been really open source kind of approach, but I think we will see a shift in that. So people will start to not publicize their results because they will be expecting business value out of that. So you cannot really count and you cannot wait and use someone else's solutions for your own business. So that's why I think it's important that everyone starts working on that at the moment.
Yeah, I agree with Elita on this completely. I think the other thing that I would add to this is actually something that Elita also referred to earlier that I 100% agree with, is that the learning to get up to speed in the complexity of the technology is so steep that if you wait and push that curve out, you find yourself farther behind. So you can sit and watch as the technology evolves and then jump in when you think it's more stable, but then you still have another delta of n number of years after that to try and come up to speed fast enough. And if everybody else has already done that and made that investment, you find yourself that much further behind. So that's an argument I tend to use that resonates well, at least at upper levels. I think the skepticism at more the shop floor is good, and we can have those conversations, but to jump in, I think the higher levels to jump in, and they hear that, right? Because if you share the sort of pressure and the speed at which the field has evolved, and just use 2020 as an example, you don't have to even go back beyond that. Then you show how quickly it's evolving, then the pressure starts. And I think that pressure helps to make the decisions a little bit quicker at the higher levels.
And I think it's okay if you don't want to go into quantum, if the CEO doesn't want, as long as you have deep enough pockets just to say, I need to buy also the competence I missed out, and this can get, really super expensive. Sorry, Steve.
Mm-hmm. No, I think I would agree with all of that. I think, but it's an area that doesn't, particularly on the application side, on the software side, doesn't need a huge amount of investment to get going. You could start off by having 1 or 2 people, run some demos, run through the tutorials, and start to get an intuition around what it's about. So it's, thankfully, it's a relatively inexpensive on-ramp, particularly for those of us kind of primarily at the software layer of the stack. So it doesn't necessarily mean you got to spin up a whole new research team and employ an army of PhDs to get into the space. You can get in relatively cheap and quickly.
And luckily, we have the startups who try to make their living, and once we missed out, we can still buy them or work with them.
The startups and the phones. Okay, when I see the questions, there are at least two questions. I think it's more for Steve. It's about the security of crypto systems and the threats by quantum attacks, Shor algorithm, and so on. Is it something you are working on in the Mastercard Labs?
So certainly something we're looking at. Shor's algorithm, I think the question was around, needs tens of thousands of qubits to work efficiently, and I think that's correct. But I think that on its own is probably too simplistic a view. One of the issues that we have is that cryptographic systems in financial services are standards and have to work across payment networks, banking networks, etc. And to change those systems is going to take a number of years. So it's not sufficient to say, can a current quantum computer or one that's going to be around in 2 to 3 years' time, can that threaten crypto systems? You've got to be thinking a decade plus out. And once you get that far out, the threat is potentially real, because we need to move an entire industry, not just a single point solution. So from that point of view, it is something that we're certainly looking at. And we announced a new standard in contactless payments and the cryptography choices that were made there were made deliberately with quantum resistance in mind. And so it is starting to feed into our thinking, but there's definitely more to do at an industry level that we need to look at.
Okay, thank you, Steve. I think we have to conclude this very interesting panel. And thank you very much for all the panelists. Perhaps if you have a word, two word, or an advice, a message to give to the audience to conclude the panel in several words. Elitsa, what do you advise us?
Well, it really depends on the audience. I believe we have people from across, really from enthusiasts to really specialists. But as I mentioned, I'm very happy, and I see the field is really growing and expanding. And I think it's going to get even more interesting in the next years. Okay. And it's great. I'm very happy to see the progress.
Thank you. Brian, Thomas, just 1 or 2 words to conclude. Thank you very much, the audience. Steve. Okay, I think I have to thank you. It was a very interesting panel. It has been an honor to be a moderator of this panel with very interesting discussion. Thank you very much, and thank you for the audience, and thank you for the organization. Goodbye.
Thank you very much. Thanks, everyone. Bye-bye.
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 I'm the host now, so I'm leaving.
Yes. So, but thank you very much. Goodbye, Thomas. Bye-bye.
Yeah, thanks, Philippe. It was really a pleasure. And we might want to talk anyhow separately after the conference.
Yes,
on what you guys are doing.
Okay, with pleasure. Goodbye. Bye-bye.